The last section we are doing in Chapter 4 is Section 4, Introduction to Functions. So first off, there are three things that we need to know when we talk about functions at the beginning. First off, relations, and all this is, it's sets of ordered pairs, so you'll have a list of different ordered pairs. Domain is all the first components. Range is all the second components when we talk about ordered pairs. So, we're going to find the domain and range of this relation. So the domain is all of the first components, or all of our x values. So we just write our x values. So we've got 5, -3, 2, -1. Now our range is all of the second components. So y values, so 6, 0, and -8. Notice this 6 is in there twice. If you wanted to list it twice, that's fine, but you don't have to. Now, a function is any set of ordered pairs or a relation in which the first component determines exactly one second component. So what this means is each x value can only go to one y value. So we're going to just go through each of these and determine whether it's a function or not. So this first one, notice that this x value, this 2, is going to two different values. So this is not a function because of this 2 right here. It's going to two y values. The second one, notice each of our x's only goes to one y, so this is a function. And notice in this case it doesn't matter that both of these numbers are going to 4s, because it's only the x's that we really care about. Now this last one, notice we have 4 as an x twice. In this case it's paired with -3, and in this case it's paired with -2, and that can't happen, so this is not a function. Each x can only pair with one y value. Now, if we've got a graph, we can use the vertical line test to determine whether or not it is a function. So if it crosses only one time, it is a function. However, if it crosses more than once, it's not a function. So looking at this first graph, notice we can draw some vertical lines, but notice they pass through the graph in more than one spot. So that means it passes through the graph more than once, not a function. This second one, we can draw some vertical lines, but notice no matter where we draw the vertical line, they only pass through the graph once, so this one is a function. Alright, so now we're going to put all of this together. So given a graph, we're going to figure out the domain, the range, and then also decide if it's a function. So for this first one, remember domain is our axis, and notice this graph just keeps going on our left and right. It keeps going out this way, and it keeps going out this way. So our x is actually can be any real number. So from -infinity to +infinity. Now our range is our y values. And so notice for our range, this is the lowest we go, but then every y value up from here gets hit. So our low point is going to be -3, but we go up to infinity. And now to decide if it's a function, Are there any vertical lines that we could draw where we'd cross this graph more than once? Well, no. So this is a function. Now on this second one, let's look at our domain. This is all the values our x can be. So notice x can be anything from here this way, also then from here this way. So it'll be actually from negative infinity up to -1. It hits -1, so use a bracket. But also from 3 up to infinity. Now our range is our y values, so it's how high up and down. Well, notice these keep going up and down, so eventually it'll actually hit all our y values. So our range is from negative infinity to positive infinity. And now, for is it a function, can we draw a vertical line that hits the graph in more than one spot? Well, we can draw a line right here. Notice it hits right here and there, so this is not a function. So same idea here. As far as notation goes, we use f of x, and that's how this is said right here. That's f of x. That's how you say it. So now, given this function, we're going to find the value of each of these parts, these expressions. So first off, notice we have f of x here, and then we have an x here. That just means whatever you substitute in here, that's telling you what value we need to put in for x over here. So notice this one we've got f of -3. That means everywhere we see an x on the right side, we're going to substitute in -3. So instead of x, -3, and now simplify. 6 minus a -12, and we'll get 18. The second one, still when we see x, we'll plug in 2a, so we'll have 6 minus 4 times 2a, and simplify what you can. 6 minus 8a. They're not like terms, so we cannot simplify anymore. Next up, instead of x, we have h minus 4. So we just substitute that in. 6 minus 4 times h minus 4. Distribute this -4, so we'll have -4h plus 16. The 6 and the 16 are like terms, so we can combine them. And we'll get 22 minus 4h. This last one's a little different. We want to figure out what x value will let us have f of x equals 9. So we know f of x is 6 minus 4x, and we want to know when is this 9. So we'll have our equation and just solve for x. So -4x equals 3, x equals -3/4. And if you wanted to double check that by plugging in -3/4 for x, you would get that your expression simplifies to 9. Alright, when we have a function, x is also considered the input value. It's what you are plugging into the equation. Your y is your output value, or what you get when you do this substitution. So when you have a linear function, this is how we're used to writing it, with y equals mx plus b. However, you can use this function notation instead of the y. So now we're going to find the domain of these. So basically we're asking, what values of x will make this work? Or think about it, is there any value of x that when we plug it in will not give us an output? In this first case, no matter what we plug in for x, we will always get a number back. So this one any number we want will work. So we can write that as negative infinity up to positive infinity, because any number is going to work. In our second equation or function, however, you can't divide by 0. And so if we were to figure out when this is 0, it's 0 when x is negative 3. That means x cannot be negative 3 because it would make our denominator 0, and you can't divide by 0. So this means everything except negative 3 will work. So that means everything from negative infinity up to negative 3, but not including negative 3. Union with negative 3 up to infinity. So this means everything from negative infinity up to 3, and everything that's greater than negative 3 will work.